Shri Sai Ram. Dear children, in this class we are going to discuss about fructose and disaccharide. Before going to the point, we will just revise what and all we discussed in last class. In last class, we have discussed about the structure of glucose. So how we have to write the structure of glucose? Only we were knowing the structure, the molecular formula is C6H12O6, right? And based on the reaction, we found the exact structure of the glucose, right? And even it's not only the open chain structure, and it has a cyclic formed structure, right? And here this is the open chain structure. Last time in last class we have wrote that open chain structure of the glucose. Here there are all the 6 carbon atoms are linked together in a straight line, and there are 5 hydroxyl groups are there. In that one hydroxyl group it is like a alcoholic group, and one CHO, that is a aldehydic group, is present. It is a functional group. Okay, and here there are 6 carbon atoms. Just name all the 6 carbon atoms here. There are 6 carbon atoms are there, and how we will write the cyclic form here? And see, this carbon atom OH, and here this one will form. Okay, right? So now, so all 6 carbon atom, and here this is H and here OH, okay, and this is OH, H, and here OH, and here this one and this one, here this oxygen is linked, right? And this is the structure. This is alpha D glucose. And there, you know, there are 2 forms are there. One is alpha and one is beta, right? And how we will write beta structure? Just only the changes of OH and H at carbon atom 1, right? And if OH is in this side, that is a beta form. So this is the alpha form. Then how we will write the Haworth structure of the glucose? You know that we took a furan structure. Furan, how we will write the furan structure? That is a 6-membered ring having a heteroatom oxygen, right? Furan. So now you just write the Haworth structure of glucose. So now you see very carefully the structure of glucose. So we know the hydroxyl groups which are present in the right side, those all are present in the below of the plane of the structure, and even whatever the H and H atoms are there above the plane of the paper, and always the CH2OH group always projected above the plane of the paper. So now you write, see this OH and next OH and next H and here OH. So alternatively HOH, and here always CH2OH is projected above the plane of the paper. Okay, and this is alpha form, alpha D glucose. So how we will write the beta D glucose? Beta D means the at carbon atom 1 the position of OH and H will change, it is ulta. Okay, so this is alpha D glucose. Just remember this structure. So we are using this structure in the again next concept. So now in this class we will discuss about the structure of fructose. Okay, so fructose is an important ketohexose. Ketohexose means it is having a ketone as a functional group. It is obtained along with glucose by the hydrolysis of disaccharide, that is sucrose. So structure of fructose. Fructose has a molecular formula C6H12O6, same like glucose, and on the basis of its reaction it was found to contain a ketonic functional group at carbon number 2nd, and carbons in straight chains as in the case of glucose. It belongs to D series and it is a leo-rotatory compound, and it is appropriately written as D minus fructose. You can see the one structure, and here just see the structure, that is a fructose structure. fructose structure, it is a ketohexose. Ketohexose means the compound which is having ketone as a functional group. Okay, C double bond O, it is a ketone, and even it is a come under carbonyl compounds, right. So here even OH groups are there, even the alcoholic OH group is also present, and this is just, it is a open chain structure, right. All the carbon atoms present in a straight line, okay, and all hydroxyl groups are attached to the carbon, different carbon atoms like glucose. And you know glucose and fructose are having molecular formula C6H12O6. When you hydrolyze the sucrose, there are two compounds it will give. One is glucose, one is fructose, right, and both are having same molecular formula, that is C6H12O6. But glucose is having aldehyde as a functional group, but fructose is having ketone as that is a functional group. That's why it is called ketohexose. Hexa means there are 6 carbon atoms present in the even fructose also. So now you have to write even the cyclic structure of the fructose now. So how we will write? See here, this one and this one, the cyclic, it will form the cyclic compound here. Just CH2OH, and here CH2OH, so this is carbon number 1, 2, 3, 4, this is 5, this is 6 carbon atom. So now at the carbon number 3, what is there? So here H, and here OH, and here OH, and here H, and here H. Okay. So now this is the, why they told that is a D minus fructose. Why it is a minus? It shows levorotatory. When you put into the solution, you know, it will turn, it will rotate in anti-clockwise direction. Anti-clockwise direction means that is a levorotatory. That's why always fructose shows the levorotatory. So we have to write minus. Okay. And now how we will write? So this is the analog with furan. Furan means the structure, this is a furan structure. Okay. So furan means, you know, you have seen this structure in first PUC in organic chemistry. So this is a 5-membered ring. Furan is a 5-membered ring having oxygen as a heteroatom. This is a heteroatom. Okay, remember furan means it is a 5-membered ring having oxygen as an heteroatom. Now we have to write the Haworth structure of the fructose now. Okay, so it is analog with the furan molecule. So now, so you can see the structure on the screen. Okay, this is D minus, this is alpha D minus fructofuranose. Okay, because furan means it is took from the furan. So now it is, we know there are two forms, even here there are two forms, the one is alpha, one is beta. This is alpha D fructofuranose. So beta means at carbon atom, this first one, and the change, this position will change. Okay, you can see the even structure on the screen. Okay, there are only just at carbon atom 1 that the position of the OH and CH2OH is changed, that is beta D minus fructofuranose. Okay, this is all about the structure of fructose. Okay, the next concept we will study about the disaccharide. So what is mean by disaccharide here? So disaccharides means when we hydrolyze the compound, disaccharide compound, it will give the 2 monosaccharides. So disaccharides, when you hydrolyze, in the presence of dilute acids or enzymes, 2 molecules of either same or different monosaccharides it will give. So the 2 monosaccharides are joined together by an oxide linkage, that is glycosidic linkage, formed by the loss of water molecule. So there are three important disaccharides are there. Those are, first one is sucrose, second one is maltose, and third one is lactose. So sucrose means, that is the source of sucrose is sugar, right, and maltose is, it is a malt, and lactose, sugar, it is present in the milk. Okay. So now one by one we will study about the structure of sucrose and maltose and lactose. The Haworth structure of the sucrose, maltose and lactose is very important even for the examination. They will ask for 2 marks. Structure of the sucrose and maltose and lactose. So first one is sucrose. So sucrose, a common disaccharide, is a sucrose which on hydrolysis gives equimolar mixture of D plus glucose and D minus fructose. We know D plus glucose also we have studied, and D minus fructose also we have studied. When you hydrolyze the sucrose, it gives a D plus glucose and D minus glucose. Okay, D plus glucose means that dextrorotatory glucose, D minus glucose means that is levorotatory fructose, right. So these two monosaccharides are held together by a glycosidic linkage between C1 of alpha glucose and C2 of beta fructose. That means there are two, beta fructose and alpha glucose are linked by C1 and C2 of respectively. So that here the sucrose is a non-reducing sugar. I have discussed in last class why sucrose is a non-reducing sugar. Why it is non-reducing sugar? Because it will not reduce on Fehling solution and tolerance reagent, because they both are having different functional group and both are having different structure, right. They both are holding with each other. That's why it is a non-reducing sugar. So now we will discuss about the structure of sucrose. So sucrose is a dextrorotatory, but after hydrolysis gives a dextrorotatory glucose and levorotatory fructose here. Since the lever rotation of a fructose, that is minus 92.4 degree, and is more than dextro rotation of glucose, that is plus 52.5 degree. The mixture is always lever rotatory because lever rotatory value is more here. So thus hydrolysis of glucose brings about a change in the sign of rotation from dextro plus and to levo minus, and the product is named as invert sugar. So it means the sucrose compound is a invert sugar. So just even see the structure here. We are taking alpha D glucose and beta D fructose here. So we know the structure of, now separately you just write, this is alpha D glucose. How we will write the alpha D glucose? Here OH, so this is the alpha D glucose. Now you write beta D so this is the beta D fructose, beta D minus. Okay. Now the structure of sucrose. Sucrose is a combination of alpha D glucose and beta D fructose. Okay, alpha D plus, this is a D plus, this is a D minus. Okay, because the fructose is always levorotatory. Okay, and here this is linked, this is a C1. Okay, linked together by this is a C4. Okay, so now you see there is a OH here is there and here OH is there, both linked together, and it will eliminate water molecule. So see here this OH and one H from the glucose, it will eliminate as a water molecule, and now you write this will linked together. Okay, elimination of water molecule. Okay, this is the structure of sucrose. Okay, the combination of beta D fructose and alpha D glucose and beta D fructose. Okay, this is very important. You have to remember the structure of the sucrose here. So next one we will study about the next is maltose. Okay, so maltose is composed of 2 alpha D glucose units in which C1 of one glucose is linked to C4 of another glucose unit. The free aldehyde group can be produced at C1 of second glucose in solution and it shows reducing properties. So it is reducing sugar. Maltose is reducing sugar. It is a reducing sugar. Okay, remember this one. So we know this is the structure of alpha D glucose and maltose is a combination of 2 monosaccharides. The combination of 2 monosaccharides same, that is alpha D glucose. Now you write 2 structures of alpha D glucose. So now again I will write the structure here. Again you write one more alpha D glucose here. This is a alpha D glucose again, and here in maltose the carbon atom 1 and the carbon atom of C4 of the another alpha D glucose are linked together. So here this is 1, this is 2, this is 3, this is 4, and here 1, 2, 3, 4, this is 5, this is 6. Okay, here C1 of the one alpha D glucose and C4 of the another alpha D glucose linked together. See here there are 2 OH groups are there, right, and here these 2 will link together by glycosidic linkage. This is called glycosidic linkage, and here the elimination of water molecule takes place because here there is one OH group was there, here one more OH group was there. So this one as eliminated as a water molecule and oxygen is as remains as it is. So here just to see the structure you have to take 2 monosaccharide, that is alpha D glucose, I linked by C1 of the one alpha D glucose and C4 of the another alpha D glucose. This is the structure of maltose. Okay. So now we will discuss about the structure of lactose. Lactose is a disaccharide found in milk and commonly known as milk sugar. It is composed of beta D galactose and beta D glucose. The linkage is between C1 of the galactose and C4 of glucose, that is a beta D glucose. Hence, it is also called as reducing sugar. So, it is a combination of beta D galactose and beta D glucose. So, see the structure of beta D galactose, and here this is the structure of beta D galactose and this is the structure of beta D glucose. And here you see this is a C1, C2, C3, this is C4 and this is C5 and this is 6, right. And here this is C1, C2, C3, C4 and C5, here C6, okay. Here the link between C1 of the galactose and C4 of the glucose, that is beta D glucose will takes place. So, here the link between the C4 and C1. So, now here elimination of water molecule takes place because here OH was there and here also OH was there, okay, one OH and one H and the oxygen will come between, and this is called glycosidic linkage, okay. This is the structure of lactose. Lactose is also called as reducing sugar. Reducing sugar means which is reduced on Fehling solution and Tollens reagent, and it is present in the milk and also called as milk sugar, because it is present in the milk, lactose. Okay, this is all about the structure of lactose. So till now we had discussed of the structure of lactose, sucrose, maltose and fructose and all. So in next class we will discuss about polysaccharides and some importance of carbohydrates. Sai Ram.